Hello. So this is Screeps. I've told a couple of people about this game lately, and it's a little easier to describe if I can show it to you. A lot of the kind of intricacies don't make sense unless you're really looking at it. So, just to dive in real quick, this is the Screeps world, and this is a private server, so it's only got a couple of people on it. The four in the corners are bots, and this one is me, and this one is my brother. And what happens is each of these rooms has different objects in it. Now, the basic one is energy, which you can use to fund most of your activities. You also have minerals, which are for more advanced construction, and then controllers, which you need to be able to interact with a room. Rooms without controllers, you simply can't turn into bases. You can still build through them, but they're not going to be upgradable or anything like that. So I'm going to switch over to my room here, and before I go into the specifics, I want to talk about how this game works, because the way that they designed the loop is very interesting, and it poses a few tricky problems when you're trying to design everything. So the game has a sort of setup that uses two features: your code and your memory. And these are fired off on a loop, each tick. So the server is set to a 1 second tick rate, which means that between all of the players, there are 1000 milliseconds available for compute time. I have a total of 100 milliseconds compute time available to me, and I'm using 16 milliseconds, fluctuating down as the tasks become simpler. I'm also using 6 kilobytes of my 2 meg RAM limit. As you upgrade your base and progress through the game, you get a global control level, which increases the amount of rooms you can control and increases your CPU limit. For now, though, 100 is more than enough, and even 10 would be sufficient if I coded more efficiently. But it'll be a long, long time before I ever start hitting any caps. So each tick, your scripts are actually closed out and then started back from the top. You cannot carry any loops or other code systems across, across a tick. There's no event-based calls or anything like that. You have to use memory. Memory is the only thing that will survive each, tick on the server. So, it becomes this game of deciding an action, doing that action, and then ending. You can see each of these creeps. They'll pause, they'll move, they'll pause, they'll move. They're determining their next step each square, each one at a time. You can't just tell them to go all the way to some specific point. With some creative memory manipulation, sure, you could mimic that, across. You can kind of make a constant loop using memory, but I'm not anywhere near that point yet. So actually, I can go into the memory here and I can show you. So I'm going to look at Transporter 4, who should be returning to base because he's full. I can see the deliver flag is set to true, and once he drops it off, it should set to false, which will change what action he's currently doing. Now he got stuck trying to decide if he wants to deliver or rest. Alright, so there's the delivery. I can refresh the memory, and we see that his deliver is now false. He is looking for energy or going to rest. So yeah, that's memory. Now, there's two types of memory. There's a global memory that you can access simply as a property of memory. So I could do memory.s equals test, and then console.log memory.s. It should print test if my console was running. Hold on. Yeah, Yeah, so prints test. I'm currently using the console to log actions so I can kind of see what's going on. You can see undefined popping in a lot. That's JavaScript being safe and fun. So, the global memory I just showed you, there's also local memory. Individual creeps and certain other types of buildings have their own memory property which you can add data to. Not all objects do have this, and sometimes it's useful. So, for example, these sources here, where I get energy, they do not have a memory property, so you can't set data on them. Now, I wanted to be able to do that, and I came up with a system that was inspired by some of the things I've seen in the community forums. And what it does is will actually create the memory for that source or that object that needs it, and then I can use that memory in my script. But since I'm creating that memory in my script, it has to close at the end of the script. So, while I can create memory on this source, and then I can use that memory through my programming, once the tick ends, that memory is gone and it's not carried over because I created it. Only the global memory can be carried over, and only the objects which naturally have that property will be carried over. So that's something to consider, but obviously you can get around it with some creativity. And you can build your own memory parsers. You do not have to use the built-in one. They offer it, but there is a way to simply override it, which is pretty cool. If you wanted to get your own performance or your own features, maybe you could you could make your own memory parser that's sorted on every tick or something. Besides that, I could go over my units real quick. So I have harvesters. These guys are work parts, just work, and move. And it looks like this guy got damaged. There was probably a fight that went on. I'm sure that's what confused my transporters earlier. So I'm just going to go ahead and send in the suicide script. So I can do game creeps harvester 2 suicide, and it will drop him out. It will also execute his on-death script, which I'll show you in a minute. But then you can see in just a moment here, the spawner, it's currently working on a unit, but once it finishes that one, it will go ahead and create that missing harvester by emptying out these extension cells. Each of these extension cells holds energy for the spawn to use, because each body part does cost a certain amount of energy. So there you go, it's creating the harvester, and it used about 500 energy. Each of these holds 100. The spawn itself also holds 300 energy, so you can use the spawner initially. These are upgrades. So besides the harvesters that dig, you also have transporters, or at least I have transporters. It's an idea that I use. Not everybody builds the same way in this game. The transporters will move energy into the main storage. I have energizers here, which huddle around the main storage and fill up the spawning pools when they are empty, so you can see them all spring into action here. I have upgrader units. These guys will sit on the main storage, and when the main storage passes a certain threshold, like a limit, they'll start pumping energy out of the storage into my controller to upgrade it. But I don't want them constantly sapping it, so I have it set to 90,000. So every time this store reaches 90k, they'll do the upgrade process. And so it's a cool game. You've got the ability to jump in for a brief period, make changes, kind of work on it over time, and the first week or so is pretty hard because you don't have self-sufficiency, and you're probably going to have your base crash a few times, but eventually you get to a point where it is self-sufficient, and you can just check in and check out as you need. You can also set up these scripts to be editable from the web. That's nice, just in case you're on the go. You can also, point your IDE or Notepad++ to this directory. and edit them that way. I've also got Git, excuse me, I've also got Git plugged in so that every time I make a big change, I can just pop open Git bash and sync it with my repository. So it's kind of what you make of it, but the eventual goal is to have constructed an AI which can spawn, achieve self-sufficiency, upgrade its room, spread to neighboring rooms, and just handle threats and just continue to grow. And I'm working with my brother right now. He's trying to get there as well. I think it would be nice to collaborate on an AI, with somebody else. I don't know anybody right now, but if not that, I could also, give my AI to several players, and we could all release it at once. And well, when I say release it, I mean on the live server. So there's a global server where everybody is, and they all have, obviously their AI is running there. So it's kind of a game to see who can make the smartest colony, most efficient, And it's something that kind of scared me away from the game when I first looked at it, because I thought, yeah, everybody's already perfected whatever system they're going to use, right? Now, that's not true. Anybody who releases public scripts tends to get hunted. There are whole alliances of players that will track public AIs that get posted and public scripts, and they'll write their own counter scripts. You can easily see the hole in the defenses or the hole in the logic and abuse it, just and wreck the players that are using them, because every script kind of has its own pattern in game. So that's interesting. And on top of that, you can build it up on a private server like the one I have right now, and you can fairly peacefully put together your machine before you go and put it on the big server. So that's also a consideration. So it's more accessible than I would have guessed. And for a programming game, it's just neat. It's got these APIs which you can reference. It's got IntelliSense built in that works with its own API. That's nice. It's all well documented. There's tons of script examples, and you can include any kind of Node packages that you want. Since this is based on Node and JavaScript, there's Lodash built in. I'm sure you could add whatever kind of library you want. I've seen some pretty cool stuff. So that's about it.